Variables, identifiers, data types. Welcome back. In the previous lesson, we learned how to write, compile, and run a C++ program. We also practiced the Hello World and average programs using the Borland C++ software. As part of the average program, we use a few variables such as num1, num2, and average. Although we use these variables, so we still need to learn what they are and how to define them correctly. In this lesson, we'll learn about variables, identifiers, and data types, three of the most important concepts in programming. So let's get started. What exactly is a variable? A variable is a named memory location used to store data. The value stored in a variable can change while the program is running. Think of a variable as a labeled container. Just as you can place different items into a container, a variable stores a value that your program can use whenever it needs it. For example, suppose you want to store a student's age. You can create a variable named age and assign it the value 20. In this example, age is the variable and 20 is the value stored inside it. Whenever the program needs the student's age, it simply refers to the variable age instead of repeatedly writing the number 20. Using variables makes programs easier to read, easier to understand, and much easier to modify. Now that we know what a variable is, let's talk about identifiers. An identifier is the name given to a programming element, such as a variable, function, class, or array. In this lesson, we'll focus on identifiers used as variable names. Let's look at this declaration, int age equals 20. Here, int is the data type, age is the identifier or variable name, and 20 is the value assigned to the variable. Whenever you create a variable, you're actually creating an identifier that represents a location in the computer's memory. There are several rules you must follow when naming identifiers. Rule number 1, an identifier must begin with a letter or an underscore. It cannot begin with a number. For example, age underscore count and student are valid identifiers. However, 2age and 9 number are invalid because they begin with a number. Rule number 2, identifiers cannot contain spaces. For example, student name and total underscore marks are valid, but student space name is not allowed. If your variable name contains more than one word, you can write it using camel case, like student name, or by using underscores, like student underscore name. Rule number 3, identifiers may contain only letters, digits, and underscores. For example, total1 and marks underscore 1 are valid identifiers. However, names that contain symbols such as @ signs or hash symbols are invalid. Rule number 4, reserved keywords cannot be used as identifiers. Examples of reserved keywords include int, float, if, while, and return. These words already have special meanings in C++. For example, writing inal followed by another int as the variable name is incorrect because int is a reserved keyword. Rule number 5, identifiers are case sensitive. For example, age, capital A age, and all capital age are considered 3 different identifiers. Always be consistent when naming your variables. Now that we know how to name variables, the next question is, what kind of data can a variable store? This is where data types come in. A data type tells the computer what type of value a variable can store. Different kinds of information require different data types. Let's look at the 5 most common data types in C++. The first data type is int. The int data type stores whole numbers. Examples include 10, 25, 100, and even negative numbers such as -15. Use int whenever you need to store whole numbers. The second data type is float. The float data type stores decimal numbers. For example, 36.5. Use float whenever your data contains decimal values. The third data type is double. The double data type also stores decimal numbers, but with greater precision than float. For example, 3.14159265535. Use double when you need more accurate decimal values. The fourth data type is char. The char data type stores a single character. Characters are enclosed in single quotation marks. For example, the letter A. Remember, a char can store only one character. The fifth data type is bool. The bool data type stores logical values. It has only two possible values, true and false. Boolean variables are commonly used when making decisions in a program. Before you can use a variable, you must first declare it. A variable declaration tells the compiler the variable's data type and its name. The general format is data type, followed by the variable name. For example, int age, float salary, and char grade. These variables have been declared, but they do not yet contain values. After declaring a variable, you can assign it a value. This process is called variable initialization. The general format is data type, variable name equals value. For example, int age equals 20, float height equals 5.8, double pi equals 3.14159265535, char grade equals capital A, and bool passed equals true. Initializing variables makes them ready to use immediately. Now let's put everything together in one simple C++ program. In this program, we declare variables with different data types, assign values to them, and then display those values on the screen. When the program runs, it displays the age, height, the value of pi, the grade, and whether the student passed. Notice that the Boolean value true is displayed as 1. In C++, true is represented by 1, while false is represented by 0 when printed. Let's review what we've learned. A variable is a named memory location used to store data. An identifier is the name given to a variable or another programming element. Identifiers must follow specific naming rules. They must begin with a letter or an underscore, cannot contain spaces or special characters, cannot use reserved keywords, and they are case sensitive. A data type tells the computer what type of value a variable can store. The most common data types are int, float, double, char, and bool. Before using a variable, it must first be declared. It is also good practice to initialize the variable by assigning it a value when it is created. Understanding variables, identifiers, and data types is an important step because almost every C++ program you write will use these concepts. In the next lesson, we'll continue building our programming skills by exploring another fundamental concept in C++. Thank you for watching, and I'll see you in the next lesson.